9.4 Congruence, Day 1. I'm going to do the simple steps of the congruence today, figuring out why figures are congruent. And then we're going to take up on it tomorrow, continue it tomorrow as well. Basically, I can find and verify that a figure is congruent to its image by using a transformation. So you take all that, and basically that's what it says. It's written up over there. I can describe the changes occurring to the x and y coordinates for a figure after a dilation. That'll be later this week. That's what we're going to be working on. Congruency and dilations. Vocabulary. Congruent. Figures that have the same shape and the same size are congruent. Here's the sign, congruent, an equal sign. Squiggly over top, that means congruent. Also, corresponding angles and corresponding sides of congruent figures are congruent. So if the figure is congruent, so are its sides, so are its angles. Congruent figures have the same size and they have the same shape. Same size, same shape. Line segments in the figure, well, they have to have the same length. And if they're congruent, angles have to have the same measure. If lines are parallel, they have to remain parallel on the congruent figure. After we do a transformation, if they're parallel on one, they need to stay parallel on the other. There are three types of rigid or congruent transformations. And these are the ones that we did last week. The three types of rigid or congruent transformations are translations, which you know as a what? A slide. Reflections, which you referred to in elementary as what? Flip. And rotations, you guys would, I had a couple different ones, but some of them would refer to it as a spin or a turn. Example 1. Triangle ABC is rotated 90 degrees clockwise to create triangle DEC. Down here it says which angle is congruent to angle A. Well, when the numbers are, when the letters are different and they're not listed as A and A prime, my hint to you, it's not so bad on a triangle, there's only 3 sides, but sometimes if you get a quadrilateral or a pentagon or something, there's more sides. So what I like to do is just go 1, 2, 3, 1, 2, 3. That way you know which ones correspond. So which angle is corresponding to angle A? Well, angle A is 1. What's the angle here that's 1? Angle D. Which angle is congruent to angle E? The B. The angle B. Which side is congruent to AC?
B and C.
Okay, so if it's AC, it's 1, 3. Can I put DC or can I put CD? Or either work?
Either way.
It has to be in the same order. AC, so 1, 3, so it has to be 1, 3. It has to be DC. The side is usually the line over top. D, which side is congruent to CE?
BC.
CE has to be what? CE, that's 3, 2, has to be what? BC or CB? Has to be CB. Parallelogram. ABC axis. Now they've already reflected it and they labeled it A prime, B prime, C prime, D prime. A lot easier to see which ones are the congruent corresponding angles and sides. So with this figure, which angle is congruent to angle D? Angle what? Yep, D prime. Which angle or which side is congruent to BC? All right, so BC is what? Side B prime, C prime. What is the measure of side AD? What is the measure of side AD? We were just talking about snow. Is it inches? Units. Okay, how many units? How many units long is side A to D? What do you get when you count them up?
10.
10? 9? 8, 7, 6, 5, 4, 3, 2, 1? I get 9. 9 units. What other sides have the same measure as AD? What other sides have the same measure as AD? Yep. This one and this one are congruent. So BC, comma, any others? Good. What are they? Yep. B prime, C prime, and one more. Yes. Comma, A prime, D prime. And letter D, side AB is parallel. AB is parallel to DC. And usually it's with these little triangle marks. That's usually how it indicates that they're parallel. They have the little, that's supposed to be a little triangle there. That indicates that they're parallel. So which side is parallel to side AB prime? Which one is parallel to AB prime? What is it? DC prime is parallel. Right here. Okay. Name a congruent transformation in each diagram. Which pair of sides are congruent? If appropriate, which pair of sides are parallel? Which angles are congruent? Well, first of all, what did they do? What did they do to the original to make the new image? They did. They reflected it. Reflection over the x-axis. That was the rigid transformation they made. Now, what are the congruent sides here? We've got triangle FGH and FGH up here. First of all, let's list the sides. What are the congruent sides? Let's start with FG. What's congruent to FG? FG is congruent to side what? That makes it easy when they're prime. F prime, G prime. We're not done. We know those are congruent. What is congruent to FH? FH is congruent to F prime, H prime. FH, that one too, that one too. And finally, the third one, what's congruent to GH? Congruent to G prime, oops, H prime. Am I done? No? What else then? How about angles? What's congruent to angle F? Angle F is congruent to angle what? F prime. Angle G is congruent to angle G prime. And angle H is congruent to angle H prime. Now, are there any sides that are parallel within that figure, that triangle? So, if appropriate, which pair of sides are parallel? Are there any parallel sides in that triangle? No, none on that one. So we don't have to worry about the parallel sides in that figure. Okay, next one. First of all, what congruent transformation happened? Is it a reflection again, like the last one? This is a rotation. What? What way? 90 degrees, 270, 180?
180.
This one is a 180 degree rotation. Congruent sides. Side XW is congruent to what? X prime, W prime. WZ is congruent to prime WZ. All right. And then we have XY is congruent to prime XY. Finally, ZY is congruent to prime ZY. Are there parallel sides on that figure? Is there a parallel side on that figure? What are they? Sides YZ, side YZ is parallel to side WX. Right? This side is parallel to this side. So therefore, what else do we know? We also know that WX is then parallel to side Y prime Z prime, and that is also parallel to WX prime. All these are prime as well, then if they are congruent, they're similar, these will then be parallel. Congruent angles, easy again when they're labeled primes. All you have to do is match them up. Angle W is congruent to angle W prime. Angle X, angle Y, angle Z are all congruent to their prime. So the angle X prime, Y prime, and Z prime. Okay, last problem. What kind of a congruent transformation took place? did. What kind of a translation? We can't just put translation. Yep, a translation. But you have to tell me what. Translation. What did we do to the x? Right? Here's my original. Let's just do the original j. What did I do to my j to get to the new image? The x is always left or right. So what did I do? I went left, so is that a positive or a negative?
-6.
It's a negative, and we went 6. 1, 2, 3, 4, 5, 6. So x minus 6, comma, what did we do to the y? We had to go up, so is that positive or negative? Positive how many? 1, 2, 3, 4, 5. So plus 5. So we did a transformation or translation of x minus 6, y plus 5. And then you just go about the same thing, listing all your congruent sides, all your congruent angles. Does this figure have any parallel sides? Which sides are parallel? Let's look at our original figure. What is parallel in that figure? Which one? JM and KL, are those parallel? Nope, you'd flunk your driving test if you park like that. All right, ML or LM and JK. So if I know angle JK is parallel to ML, what else do I know? What else is parallel then? JK prime is parallel to angle M prime L prime. And then you would list all the appropriate angles like we did in the other ones. Okay? Your homework. New packet today, pages 1, 2, and 3 in the new packet today.